answers for those two questions. So if you're just wrapping one of them up, just keep your head down and wrap it up or whatever. But I wanted to show you the answers for those that are done. For numbers 1 and 2. So number 2, I'd say, has a little bit of a trick to it with maybe a trig identity somewhere in there. I don't know how you handle that. Number 1, there are parts that are really straightforward, and then there's that one part with the absolute value that's kind of tough to handle. When I give you a chance to look these over, and we can certainly discuss as you would like. I hope that you guys are not shy. I think you probably understand this. Like when I try to explain something, like in my head, it always sounds great. But if what I explain confuses you, you're not going to make me mad. You're not going to make me sad. If you say, I didn't understand that, it just means I need to figure out a different way to show you. Or maybe a classmate has a good idea, something. We just need to figure out a way. So if you ask a question and I answer it and you're more confused after I answer it, just keep at it. So it comes from the fact that y is always less than 5. If you were going to try to do the absolute value of y minus y, I don't know, it kind of depends on what y is. You have to consider both cases. And because I gave you that information, it allows you to
it's because it's negative. Yes. So it's still
do well. And the absolute value of something that you know to be negative is the negative of that. And once you get there, I see distributing it or dividing it over. There is so
wait, I think you just divide.
Oh, you're good. I saw you out there. That was pretty fast. Pretty fast for you to get up here after all that. Good work. Okay, I'd love to answer questions from you if you've got some. Anybody wondering about that absolute value in number 1, like how all that worked out?
Yeah.
Like, I think where most people are going to have a question is, where did that come from? Like, why is that there? So let me see if I can help you by getting you to think about a couple of things that kind of go along with that. Kind of like, Catherine, what I was talking about with you. Just go through this exercise with me. If I said, what's the absolute value of negative 12, what would you all say? 12. What's kind of missing from that, and I think sometimes in middle school or early high school, we kind of do a little bit of a disservice when we just go with that. I would say that the absolute value of negative 12 is actually negative 12, right? Because if you want to go from a negative number to a positive number, don't you have to negate the negative? You have to do the opposite of the negative. And of course, negative 12 is positive 12. And if I were to say, what's the absolute value of 12, you would say 12, right? So that's not too hard to do. But then if I were to ask you a question similar to this one, if I said absolute value of x, what are you really tempted to say? X. You want to say x because it appears that the thing in the absolute values is positive, and so the absolute value of a positive. The thing, though, how do you know that x is positive? You don't. It could be 0. It could be positive. It could be negative. We have no idea what x is. So I would have to go with this. I have to say, well, absolute value of x is, well, if x is I'll put it like this. I'd say absolute value of x is x if x is positive. Right? If that number in there is positive, then the absolute value of it is just that number. If that x is negative, then what's the absolute value of x? Negative x. Make sense? It's a hard one. And then, of course, if x is 0, then the absolute value of 0 is just 0. And this is a form of the absolute definition of absolute value. So when we go back to our blue question there on the left, and we try to evaluate the y, absolute value of y minus 5, we have to ask ourselves, cool, is y minus 5 positive or negative? We have no idea, at least at the start, right? Y minus 5, it kind of depends on what y is, right? If y is a number like 10 or 11 or 12, then y minus 5 would be positive. But if y is like 0, 1, 2, 3, then minus 5, well, then that whole thing would be negative, wouldn't it? And that makes a difference. So what is the one clue that I gave you that allows you to figure this out? y is less than 5. So y would be numbers like 4, 3, 2, 1, 0, etc., negatives 2. And if you take a number like 4, 3, 2, 1, 0, dot, 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 minus 5, what do you always get? A negative. So I know then, based on that, I know for a fact that y minus 5, at least for this particular question, will always be negative. And since y minus 5 is always negative, to make it a positive, what do I have to do? Do the negative of that. And that's where this comes from. Because I know that y minus 5 is negative. To absolute value it, I have to do the negative of that. And of course, if I told you that y was always bigger than 5, we wouldn't need that minus sign, would we? We would just say, hey, y minus 5 is always positive, so the absolute value of it is always y minus 5, and then we move forward from there. Anyways, that's usually the hard part. How do I deal with that absolute value? Okay, so this is where you can be honest. That all sounded great in my head. I hope it sounded great in your head too. If it didn't, you need to say, I'm still confused. And we all get confused at times. So I'm okay with that. Do you have any questions? Anything? I hope I explained that well enough, at least for now. Nobody's saying anything. Okay, how about number 2? A little bit of a trig identity, and then once you get there, kind of the unit circle, special triangle routine, hopefully worked okay. Yeah? Any questions on 2? When you're doing 2, is anybody like wishing you could have a calculator? Like if I could only do that? No. So if you're feeling comfortable with the unit circle, that is fantastic. That just needs to be something you're very, very good with. And if you are, then there will be a lot of questions. The finish will be very easy. So that's great. Really, really good. Okay, you're all looking pretty confident. Just reading faces. Am I correct? Fantastic. Okay, cool. So we're going to jump in, and I am super excited to see what you all do with this. So take just a minute here, or there we go. Take just a minute or so here. I want you to do this first one here. Discuss with your partner, folks at your table here, what is a limit? And leave yourself some space to write some other stuff, but I want you to write it down. Leave space to write other stuff, but somebody said, I saw this living thing, what is it? What is it? I can't remember. You guys remember doing limits at the end of the year last year?
Yeah.
And you did a little derivative stuff too, maybe? Okay. It's been like 3-4 months, but maybe you remember a little bit about it.
Yeah. Wait,
Okay.
can you talk with Mr. Blake and tell him to give his DCP calc class more than 10 tries?
So he's the king of his class, so I will let him do what he sees fit. But we will certainly, we'll certainly have that discussion. I believe pretty strongly in what I do and why I like to do it. So
Like at least 5, because it's just like that.
I know there's a lot of pressure, right? You try the first 2 and you're like, oh no, it's try number 3, and yeah, I get it.
And then you realize that you did.
I get it, yeah. I like to try to take that pressure off you in practice.
Sometimes I'd like to submit my third answer, and then I realize it was wrong right after I did it.
Or if you do a T instead of an X or an X instead of a T, some like minor little notational thing that you can fix pretty easy. Yeah. I actually wish WebAssign would give you a hint. Like if you did something silly like that, WebAssign would be like, think about your variables, or like it would give you a message like that. If you had the right answer, just the wrong letter or something. And they do capitals too, right? In WebAssign, like if it's a capital R and you put a lowercase r, they're like, nope.
Wrong, yeah.
Because technically it's wrong, but I wish they'd give you a hint. Like, look at your letter or something, Yeah. Okay, want to hear what you guys have to say with this question, what is a limit? Just throw it out there. Just want to hear what you have to say. I have no idea what you're going to say. So somebody, you've been discussing and you came up with blank.
We have a few words, but we don't know how to put
Okay.
them together in the correct order.
What are some of your words?
As X approaches something.
Okay. No, this is
something gets
moving us.
infinitely closer,
Listen.
and that's.
This might not be like a well-crafted sentence, but isn't he saying he's saying a lot of like nice elements that we're looking for here, right? As X approaches something, something's getting infinitely close to something else or whatever. Sure. Again, probably not like a final product, but some good thoughts, right? Anybody else have something to add to that? Even if it's just like a snippet, like what Joey said. No? Are you going to make me do all the talking? Oh, Brian.
As X approaches C from either side and f of X approaches L, the limit as X approaches C is L.
Sure, that's like a
Really had to say that like a million
Yeah.
like it's somewhere deep in the back.
I was going to say that sounds like a very bookish definition.
Yeah.
Sure. So I tend to do things like we can get formal like that. I tend to try to do things accurately, but a little more informally because I want you to like think about it and get it into your own words as best you can. So I don't have this pre-rehearsed. Everything Brian said I think was right. He said it kind of fast, but I don't think he made any mistakes or anything. I think that was a pretty well-worded sentence. So I'll throw this out here. You can write this down in your own words. I'm going to say it's going to be, a limit is the pattern of behavior of y from both sides of a specified x value. It's the pattern of behavior of y as you consider that pattern of behavior from both sides of some specified x value. And that's, like Joey said, as x approaches some number, that's my specified x value. And the infinitely close is kind of this pattern of behavior. And I do have a super high-tech illustration for you of this. And it's not that high-tech, actually. So let's just do a little for instance here. Let's say we're having class, and I'm wandering around up here. I'm talking, and you're talking, whatever's going on. And we're still talking, and you see me kind of like wandering towards the doorway. I'm getting over here. I'm just kind of moseying on over here towards the doorway. And I get like right about here. I'm getting really close to the doorway. And then something out there, like on the street or something happens, like maybe a really loud car crash or a loud noise or, I don't know, something really distracting happens out there. And I want you to do this. Like all of you really quick, just like look out the window. And then you look back over towards me once you realize it is, and now I'm in the hall. And I'm out here for some reason talking out in the hall and doing this number. I don't know why I do that, but let's just pretend that's what happened. So, no one, because you got distracted, no one actually saw me standing in the doorway, did you? You never saw me standing like right here. You saw me wandering around over here, and then you got distracted, and then you saw me over here. This is kind of a nice illustration of a limit, because even though you never saw me standing in the doorway, wouldn't you say, well, his pattern of behavior was heading towards the doorway. We didn't actually see him in the doorway. Then we got distracted, and then he was on the other side of the doorway. So wouldn't you say, I don't know if he ever actually was in the doorway or not. Maybe he has a special secret power where he could like teleport himself over short distances.
Got a secret door.
There's some kind of special secret door. I mean, we don't know if any of those things are true or not. But wouldn't you say that my pattern of behavior from before and after would be the doorway? I was headed there and then I was leaving there, right? And so you'd have to say like the limit of me moving around would have to be the doorway. Even though you never saw me in the doorway, you'd say my pattern of behavior was the doorway. And it really doesn't matter if I teleported or had a secret doorway. It really doesn't matter. The limit would be the doorway. We don't really care if I ever stood there or not if we're talking about a limit. Does that make sense? When I say pattern of behavior of the y from both sides, that would be sort of an illustration. Make sense? I think I've got a really good second illustration for you, and it's number 1. Number one. This might challenge what you've thought of with limits in the past. This might tempt you to do some really egregious math errors, possibly. We'll see. I want you guys to discuss. I want you to look at this, and I will say this. The only thing you can't do is you can't get your phone out and Google this, because that's just weak. Beyond weak. That's embarrassing for you. But you could use your calculator. You could use any feature on your calculator. You could use each other to discuss. I want you to try to figure out what number one and that limit is. Is it out of batteries? Well, you can peek with these guys. Oh, one note, make sure you're in Radian mode. We'll always be in Radian mode in this class. Remember the other one? So please be in Radian mode if you're going to do like a graph or a table or something. If you're in physics as well, it's going to be tough because physics wants the other mode. I'll always remind you that. Yeah, there is a hole there. By the way, if I were going to use my calculator, I would input this one. I use like a table or a graph or something when you're doing summations with this one. Table or graph should serve you pretty well there. Be careful with that. That's
at 0, it doesn't actually.
the number you have listed there is potentially the right answer. The way you have it labeled is ouch. You might have to plug into it. And I don't know what FX is. No point is there an FX anywhere on this page. Yeah. Okay. First of all, let's do this first. Does anybody have an answer? You have a numerical answer to this. What do you think?
1.
Anna says she thinks the answer is 1. Does anybody on her side with that? You agree with her? You got some support here. Anybody think it's something other than 1? Okay, so let's start off with that as a possible answer. Anna, how did you arrive at that answer?
Duho whipped out his graphing calculator, and we traced it, and it looked like it crossed 0, but
Okay.
it didn't.
So yeah, let's talk about some details here. I would say, I hope I'm not trying to be mean or anything. I would suggest rarely, if ever, should you use trace. It is incredibly inaccurate for the most part. I mean, it might be good enough to do a limit. I think this might actually be a somewhat appropriate use of it, but it's just not that accurate, not as accurate as we want to be. But one thing you said I think is really good. Duho graphed it. Did anybody else graph it? I think that's a smart move. When you graphed it, did you get something like, I don't remember exactly, it kind of does this, right? Oops. And it goes, it's supposed to be symmetrical, right? Something like that. And then it continues on. Okay. Did anybody notice that there was kind of an interesting feature right there when x equaled 0? What's there? Oh, that doesn't exist in a hole, somebody said, right? Yeah. So if we were to accurately graph this, we'd have to put one of those open circles there. And what does the open circle mean? Yeah, the graph doesn't exist there. There is no y value right there. Okay. So if someone was confused about what a limit is, and maybe you put this, and that's okay, you might have said that the answer was DNE. And that would actually be wrong, and the answer is 1. What Anna and many of you said, 1 being an answer, that's correct. It is. You could use a table or that graph to see that, perhaps. Why might someone say DNE? What do you think, Allie?
Probably because they went and put when x equals 0, and then they saw that there wasn't a point there, so they just assumed that since there wasn't a point there, couldn't be a limit.
That's so well said. And if somebody were to consider that line of thinking, aren't they confusing a limit with the actual y value of the function? Now, the y value doesn't exist. I don't think we can argue that. But the limit does, because wouldn't you say that the behavior from the left and the behavior from the right, it's heading towards the same y value, and that happens to be 1. Anybody use a table to kind of look this over? Yeah, a table would be another good strategy. Depending on how tight you made the table, you can see this pretty well, I think. So I do want to address real quick, Allie mentioned this a little bit. Last year when you guys saw limits like this, didn't your teacher say, try to directly substitute, just plug 0 in? So you might have said, hey, let's try sine of 0 over, oh my gosh, you can't divide by 0. And so this is where someone might be led to do some really awful stuff. They might have said, well, you can't divide by 0, I know that much, so why not do... You might need to avert your gaze here. I don't know. This is going to be pretty controversial, and they might try to do something like that and get,
I would have done that.
the x's divide out, limit is, and go. This is like really, really bad, right? You can't do that because it's not sine times x. So all this stuff would be really, really bad. This would be where some of the strategies that you used last year on this particular question aren't going to work, because you saw these last year, right? Where it was, limit as x approaches 0 of x squared minus x over x. You saw a bunch of these, right? You realized you would divide by 0 if you tried to directly substitute. And so then you factored, and you got x times x minus 1 over x, and then you canceled. That's valid, right? You got -1. We will do things like that. We will for sure on Monday. I just want to let you know that that's not just what limits are. Limits are the pattern behavior in a graph. A table could be extremely helpful and might be the only way, at least at this point, we could do it. Does that make sense? Okay, cool. So I have some examples for you. If you flip over to the next page, this is a big set. It's all based on a graph. And I wanted to make sure that you all... Why isn't it advancing? There we go. I want to make sure that you all are doing okay with some of this notational stuff. Maybe you've seen this, maybe you haven't. Do you guys know what... I'm going to highlight it. These little minus signs and plus signs that are exponents. Do you know what those mean? Yes. So if it's a minus up there, it means from the left. And if it's a plus, from the right. Okay, I want to make sure you guys knew that. You could try all of these. We'll go over some answers here in a few minutes. So again, please work together, help each other out, and see how this all goes. There we go. But since we lost our time yesterday, I'm going to do this. So please check your answers. There might be some slightly alternative answers that we can discuss. And if you have questions, let's talk about those. Check what you've got against what I've got. Yes, ma'am.
You said to assume that there's a value
So yeah, this is a nice conference. Why is this?
The dot at x equals 0 is just not gonna
Yeah, but it's a single point, so you can't really say from the left to the right, it's just like one.
Well, we don't know if infinity, we don't know.
Good question.
Maybe it doesn't exist because it's not actual.
Yeah.
Because the sign just says this, but it's infinity, and infinity is not an actual x value, and it's not.
D.
We know that
What
it's
did you
either
put for
gonna,
D?
we know that it's gonna be a negative one.
I'll draw it here on the graph. Hey guys, let's talk real quick about D. So D says, please, D says we're approaching -2 from the left. And so that, of course, would be approaching from this direction. And as you approach -2 from the left, do you see how the y values are negative and get more negative, right? And as you get closer, you cozy up towards that -2 from the left, the y values are getting even more negative, right? Extremely negative. And it appears from the graph, at least, that pattern of like continuing down doesn't ever stop. And so what's down there? Just more negatives. And so that's why I would say negative infinity. You could actually say for letter D, you could say DNE as well, because infinity is not a real number, and so the limit doesn't even really exist. But negative infinity is a nice description of what's actually happening. Does that make sense? Okay. Anybody else real quick? Joey?
Yeah, so for like C and G,
Yeah.
can you just explain why that's D and E? I remember
Yeah.
from last year now, but
So as you approach, let's just talk about C for now. As you approach 4 from the left, doesn't it appear that the pattern of behavior from the left is heading towards a y value of 2? But if you approach that 4 from the right, we're heading towards a y value of 4. Because the pattern of behavior is different, there really isn't a pattern of behavior. They're different.
Right.
And so that's why we would say D and E for both.
so then why is A 4? Because there's still two.
Yeah, but the pattern of behavior from the left and the right is the same.
Oh, okay.
So from the left, we're heading towards y value of 4. From the right, we're heading towards a y value of 4. And so even though, like at that one single point, the graph drops down, the pattern of behavior is the same.
That makes sense.
Yeah. Any other questions? Yeah, Brian.
I was just wondering for D, we had that question on the test of quiz. Would you rather?
I take either one. I like negative infinity, but I give you credit for either one, for sure.
And for, I just want to make sure on I, since there's like 2 points, but it's just asking out from 0, it's just asking for a point.
It's saying when x is 0, y is blank, y is 1. Because that's the actual location of the graph there. Yeah. Hey, I know we're right up against our time. Can I take one more second of your time, one more minute, and make sure we're like caught up with the other classes? Just take a second. So we're going to skip that next one, and I want to make sure you guys can summarize this up. This will help you for your homework a little bit. What graphical features can cause a limit to not exist? There are 3 of them, and I think 2 of them you should have pretty good. Come on. What would you guys say is the first one? What would make a limit DNE?
Oscillation.
Oh, that's the one that we didn't actually cover, but yes, oscillation is true. So I'll make that number 3. We're not gonna make that a big focus of our class, but that would fulfill a complete answer here. What are the 2 we looked at here in class just now? She's got the right hand motion. What is this? Different behaviors, right? Yeah, 2 different behaviors. So I'll put, you had the right hand motion, so that's a good start. Different behavior from the left and right. And what's the other one?
Infinity.
Yeah, so I'll say if you're heading towards plus or minus infinity, like if you're dropping off the bottom of the graph or going off the top of the graph, technically the limit doesn't exist. So I'm sorry to keep you 2 minutes there. I want to make sure we're good. If anything was confusing because I went fast,